Hello and welcome to a quick update video for the previous video about water-based wireless redstone. I've received a comment from YouTube user Silicon42 who had a few good ideas to note, which I took to heart and made some improvements to the designs and also added some new creations. And I quickly want to go over what changed from the previous version. There are 4 new things that will be content of this video. Firstly, I've made the transmitter a lot less laggy. Secondly, there are more compact wireless redstone receivers now, which I've cramped together even more. Thirdly, I have created a duplex signal system for transmitters and receivers so that you have more frequencies you can use. And lastly, we're going to talk about more robust globally synchronized clocks. Okay, firstly onto the transmitter. As you can see, it looks a bit different now because I've punched out about 3/4 of all the blocks. So about only 3/4 of the blocks really get pushed upwards, and this is because if you push up the soul sand in the middle, it creates the bubble column in the middle, and what we need is water updates, but we only need one bubble column really for these 5 water columns here, because where every bubble column updates all the adjacent columns as well. So in a system like this, it's really sufficient to get all the water updates. And if you want to put that into the square over there, you can punch out, you can put these star-shaped or these pluses, you can put them really tightly packed next to one another, or if you look at the top of it, it sort of looks like a windmill. And if we use that pattern, we get the same amount of water updates, but a lot less amount lag, because less pistons, less model updates with the bubble columns, and yeah, it's an overall better solution. You do have to look out on the border. There are some blocks that do not have a neighbor, which is a bubble column. That's really what you got to look out for. For example, this block, there's no adjacent block with soul sand, so this one needs to be soul sand, this one needs to be soul sand, and right here and right here. And now we get all the water updates from this square, and I've made this, I've altered this in the same way. Also, I've got it set in so that there are no water bubbles whilst the receiver is not working, because those water bubble columns, they create some lag as well. Okay, works the same way, but a lot less laggy. Okay, on to the second part, compacted receivers. This was the design by SNAS from YouTube. This was a little bit more compact, my design. Both have the flaw that if you were to activate them, this one once activates, and this does the opposite. If you let it run and you deactivate it, you also get an output. It's not really that nice if you have an output while activating or deactivating the device. So I've altered them to use the same checker as with the one-wire tileable design, because the one-wire tileable design does not create a pulse when it's activated or deactivated. So I've used that. Let's turn it off real quick to create this more compact version right here, which is only 6 blocks long, 4 blocks wide, 4 blocks high, which is, in my opinion, quite compact and ideal. It's really nice, I think. It still works the same way. Your output is right here, and the blue part here, the delay circuit, you can still use the exact same delays as for this version. And the same goes for the one wire tellable one, this delay right here. You can also use the same delays from this one. I think, at least. It could be a little bit different. Okay. Anyway, if you're going to be building this, use it in conjunction with these. Again, this is the new compacted version. I just hover over it so you can build it if you like. This is the same clock, wraps around. Then here, sticky piston, target block, 2 ticks delay, 3 ticks delay. Then the signal goes over to turn the dispenser back off. And right here we have 2 observers, a sticky piston here, and this needs to be a class block so the piston doesn't get power by this register. Okay, that is the more compact receiver design. Up on the agenda, duplex signals and transmitter and receivers. I've created this encoder right here, which is an automatic encoder, not manual, meaning that there is a red coder up in here, which can select only a single channel depending on a comparator signal. So what we can do is we can create a 2-part signal by using 2 frequencies between 1 and 15. So right now I've got signal 1 on 14, and you can select the signal by switching through these pages here, and second signal is 15. And if we click submit, then these 2 signals will get sent, and the second signal will get sent. And yeah, quite simple construction really. The way it works is we pulse the entire circuit, and since these always activate if there's a change, we have an on pulse and it activates the transmitter, and an off, then it activates them again. Again, we have a pulse lengthener to accomplish this, the holding of the redstone power for a certain amount of time. A globally synchronized clock with output, and this is basically a rising edge, falling edge monostable circuit. The first time it activates, or if the signal gets powered, we activate this side and push the comparator signal from this selector through here into the red coder. And if the pulse down there falls, then we activate this side and let the other comparator signal get through. And after some delay, which is hard-coded right here, the transmitter fires. So if we wanted to look at it in action once more, you can see 14 will get selected, then we transmit it, 15 will get selected, and 15 will be transmitted. Of course, to utilize this, you also need a receiver that can receive these signals, which I've built up right here. Basically, it's the same, exactly the same as the compact version, the back, only that we have globally synchronized clocks that goes into 2 different hard-coded delays, then a water checker for each side. And we have one side that goes first in the signal. In this case, it's 14 goes first. 14 powers this pulse lengthener, and the activation of the pulse lengthener allows signal to get through on the other side, and but only for a short amount of time. And if in this frame of time a signal comes along, then it gets through, and we have indeed received a signal of the kind 14, 15. And if we want to demonstrate that, oh, I should turn it on, of course. Oh, guess we were just in time. I was just in time to turn it on, but I'll demonstrate it once more, just in case you're not trusting me. I get a signal through on the right side, turns on the thing, torch turns off, and this side is free. Pulse gets through, and after it pulses through, the repeater gets locked again, so there no single 15 signal can turn on this device. Of course, if you spam signals of the kind 15, 14 next to one another, then maybe you get a 14-15 combination. but I don't really think that you can spam click this encoder to abuse the system really. So if you leave the slightest amount of gaps between sending signals, then it should really be an issue at all. Yeah, if you want to build it, this thing, I quickly fly around it once more. This one is on 3, this one is on 2. Yeah, clock's the same, delays are exactly the same as in the compact version. Yeah, okay. So much for that. What else? Oh yeah, and since the red coder can only go up to 15 signals, your total amount of signals, duplex signals, would be 15 times 15. So that's 225 signals. Yeah, I think that should be it. I'm just thinking, if you get to if you, for example, have the duplex signal 2, 2, will the receiver work? I'm not sure, but I think it should work. Yeah, maybe it's not full 225, but it should be somewhere around 200, which should be enough. If you ever run out of channels, you can switch to the duplex system to get more channels. And the channels 16 to 20 will always be reserved for single simplex signals, since they cannot be encoded on this encoder right here. Or you can reserve some signals for or some frequencies for other things. For example, say duplex signals are only allowed if they use frequencies 1 to 10, and everything else is reserved for simplex signals. Okay, fourth point, more robust globally synchronized clocks. One other problem with globally synchronized clocks, as I've been told, is that if light updates were ever to miss a pulse, this clock could turn off. And I've thought about 2 ways that you can fix this. Down here we have the globally synchronized clock, and I'm gonna push a block in there and turn it on. And I've added the blue part was the usual part, and what I've added is the red part around here on this side. This is a, as you can see, always when the pulse is fired, there's also one pulse that also toggles this piston. So if the light detectors ever don't toggle the piston for 1 tick, this circuit will toggle it. So if a single pulse is dropped, that's not a problem, because this circuit right here will toggle the piston. And I can demonstrate it. If I pull it out for 1 tick, or if I pull it out, you can still see how fast I can't can't remove the block, or else the circuit's not gonna work. How do I demonstrate this? Maybe you could see it right there. I can pull it out, the piston doesn't push, but still this circuit allows it to toggle once more. And also this part right here is also powering this line, so there is no cycle where we don't fire the receivers. Okay, if you ever get problems, try to add this part of the circuit. It might fix your problem. One other thing I have is if it says off long enough, then of course it will shut off. Is this part right here? This has a redstone dust which updates, which gets updated by the signals of this and this one, and this will self-start the receivers every time this redstone here updates, which happens around every 30 seconds, I would say. Yeah. If you still don't like the idea of using this light switch clock, light detector clock, you can also just use the same restarting circuit, which I've put up right here, in conjunction with a regular redstone clock. So I fucked that up, I guess. Let me put this here. So every time, why is this not putting through? I'm confused. No, now that's working. Okay. Had to remove that. So you can build this, and the regular. Oh, that's badly out of sync. That's badly out of sync. Now I've had to change this up since I tried to add an off switch, but in the end my off switch broke the clock. So I just changed the time to daytime. The redstone updated, and that update is in sync with the other world clock, and we start a regular redstone clock. And as you can see with these no plugs and lights, these two observers right here, they are in fact equivalent. And if you can use this entire thing where this thing was. But I've had problems turning this thing off. You have to break at least this one redstone. You have to at least push up the piston, and it will reactivate because this circuit is active. And now you can see it reactivated. So if you ever run into that problem, this might be a solution to use. Okay. I think that's for written. That's all for written for right now. And yeah, if there are any more changes, I might do a third video. Who knows how long this will keep going. I really urge you to try out the new receiver designs and the new duplex system. The same as in the last video, I will put a new world download in the description. Thanks for watching, and goodbye.